Hi, in this video I am going to discuss Edexcel IAL Mathematics Mechanics M2 January 2023 past paper. All the questions will be discussed in this video. Okay, the first question in January 2023 Mechanics M2 paper. A truck of mass 1500 kg is moving on a straight horizontal road. The engine of the truck is working at a constant rate of 30 kilowatts. So that's the output power of the engine. The resistance to the motion of the truck is modeled as a constant force of magnitude capital R newtons. At the instant when the truck is moving at a speed of 20 meter per second, the acceleration of the truck is 0.6 meter per second square. Okay, so we'll show this on a diagram, whatever mentioned here. So there's a truck moving towards right, we'll take it. That's a positive direction. So the power output 30 kilowatts, it's given there. And it's moving, when it is moving, there is a resistive force acting on it, that is R newtons. So when the speed of the truck is 20 meter per second, so at the moment when it travels at a speed of 20 meter per second, its acceleration is 0.6. So acceleration means along the direction of motion, 0.6 meter per second square. Okay, these are the things given there. Later, first part, find the value of R. Just nothing. Find the value of R. So you can use the Newton's second law, F equal ma. Okay, so we know the power output. We know power is equal to A part. Power is equal to force into speed. We know force is the actually forward thrust given by the engine. So I didn't show that, so I should show that also. There's a forward thrust also, that or the truck, there's a forward thrust Ft also acting. Okay, so what are the forces acting on the truck? There are only two forces, but vertically normal reaction, downwards weight, we are not going to consider them because they are not in the direction of motion, so we can ignore them, normal reaction and the weight. But the forces that involved in the motion is thrust provided given by the engine due to the work done by the engine or the power of the output of the engine, that provide a thrust forward force Ft, and the opposing force, the friction, capital R. So we can find the Ft. So the power is given as 30 kilowatts. So 30 into 10 to the power 3. Force is the thrust Ft into the speed is 20. So speed is 20. So from that we can find the forward thrust. Ft is going to be 30,000 divided by 20 Newton. So the forward thrust is 1500 Newton. Okay, the question is, he has to find the R, the resistive force. Now we can use, we know the acceleration. Along the direction of motion, we'll use F equal ma. So force, what are they? Forward thrust minus R. The resistive force is opposite to the direction of motion, so it's minus R, is equal to ma. Mass of the truck is given, that is 1500 kilograms given. So Ft we know 1500 minus R is equal to, mass is given 1500, mass 1500 into the acceleration 0.6. Solve it and make the R subject if you want first, or you know how to solve it. If you solve, you will get R is equal to 600 Newton. You know how to solve, bring it to the right, bring it to the left, you know how to solve. So R will be 600 Newton. Okay, that's a part. Okay, B part. Later on, the truck is moving up a straight road that is inclined at an angle alpha to the horizontal, where sine alpha is given 1 over 8. So if sine alpha is given 1 over 8, we can find the cos alpha and tan alpha also. Sine alpha, if this alpha 1 over 8, so this will be square root of 64, Pythagoras theorem, 64 minus 1, 63. So we can find sin alpha is given 1 over 8, cos alpha will be square root of 63 over 8. Yes, square root of 63 over 8 is the cos alpha. If we need, we have to use the cos alpha also. Okay, so the question says that the resistance to the motion of the truck from non-gravitational forces is modeled as a constant force of magnitude 500 Newton. So the resistive force now is 500 Newton. The resistance to the motion of the truck from non-gravitational force is modeled as a constant force of magnitude 500 Newton. Earlier we found when it is moving on horizontal road it's 600 Newton. Now it's 500 Newton. The engine of the truck is again working at a constant rate of 30 kilowatts. So the forward thrust will be the same. Okay. Yes, no, not the same because the speed could be different. Yeah, so sorry, it won't be same, but the pattern is the same. The equation is the same. Power is equal to F into T, Ft into V, but V is not given. So depending on the V, it could be different, the forward thrust. Okay, so the speed of the truck is V meter per second. And the deceleration, so when the speed is V meter per second, the deceleration is 0.2 meter per second squared. Deceleration means opposite to the direction of motion, acceleration. If the acceleration is along the direction of motion, the object will accelerate. The speed will increase gradually. But if the acceleration is opposite to the direction of motion, the speed will decrease gradually. So that is called deceleration. So the deceleration is 0.2 meter per second squared. Means if the truck is moving upwards, the acceleration is along the slope downwards, which is 0.2 meter per second square. Find the value of V. So we'll show these things on a diagram. So that is big part. We'll show it on a diagram. Moving up. So the truck is moving up. This is the inclined surface. This is alpha. So this is the truck moving upward direction. So when it is moving upward direction, there is a friction they are giving, that is 500 Newton. Also, the component of the weight will act along the slope down. Say for example, on an inclined plane, if you keep an object, something like this, its weight will act vertically down, mg. This is alpha. So this angle is 90, means this is 90 minus alpha. So the weight could be resolved parallel to, we know a vector could be resolved, a force could be resolved into any two right angle direction among them, perpendicular directions among them. Normally we resolve horizontally and vertically. Horizontal, vertical, they are perpendicular among them. But not only horizontal, vertical, we can resolve a vector, for example, a force into any two right angle direction. That means along the slope, perpendicular to the slope. So if I resolve the component of the weight, if I resolve the weight along the slope down, the component of the weight along the slope down will be mg cos 90 minus alpha, cos 90 minus alpha, sin alpha. The component of the weight perpendicular to the slope will be mg sin 90 minus alpha. Sin 90 minus alpha means mg cos alpha. So the normal reaction will be in this direction. So when the truck or whatever the particle moves along the slope, up or down, perpendicular to the slope, there is no any acceleration. So perpendicular to the slope, the resultant force must be equal to 0. So if you consider perpendicular to the slope, we normally draw like this. We consider perpendicular to the slope, there is no acceleration because the particle is moving along the slope. So there is no motion perpendicular to the slope. Slope means according to Newton's first law, there is no resultant force. So R minus mg cos alpha must be equal to 0. That means R, the normal reaction, is equal to mg cos alpha. Okay, we will do later certain questions. We might use this one, R equal mg cos alpha, when object kept on a slope. And the component of the weight along the slope down will be mg sin alpha. So there will be a component of the weight along the slope down, that will be mg sin alpha. So now they are saying it's decelerating. So decelerating means acceleration opposite to the direction of motion, that is 0.2 meter per second squared, or along the direction of motion, if I put arrow other way, I should put it with positive minus sign. If I put it downwards, I can put it positive sign. Along the direction of motion, I should put the speed acceleration minus, because it's a deceleration. Deceleration means acceleration is opposite to the direction of motion. So if you invert a vector, it will get negative sign. So if I say the vector towards left is A, the same vector towards right is minus A, is it? So acceleration along the slope down is positive 0.2 meter per second square, because deceleration means acceleration opposite to the direction of motion. You should understand that. So acceleration along the direction of motion, it's moving up, should be minus, because actually acceleration is along the slope down. Okay, then there will be a forward thrust. Due to the engine, there will be a forward thrust also. So the speed of the vehicle is v. They are telling us too much of information shown, but anyway, the speed of the vehicle is v. Right. We need to find the v now. Okay, so we know that power equal to forward thrust into speed. Power is the same, 30,000, because 30 kilowatts, 30,000 is equal to Ft times v. V is unknown here. That's a question we need to find it. So Ft is equal to 30,000 over v. Okay, so that is the Ft. Now we need to find the speed. So along the slope up, we use F equal ma. What are the forces acting? Ft is acting along the slope up. The component of the weight acting down, so minus mg sine alpha minus resistive force 500 equal to m a. Anyway, it's going to be minus 0.2. Okay, we'll substitute the known values. Ft we don't know, but we can substitute Ft 30,000 over V is the Ft. Mass is given 1,500 into 9.8 sin alpha 1 over 8 minus 500 equal m is 1,500 into negative 0.2. So I can say minus 1,500 into 0.2. Okay, everything we know except we solve it. You will get V is equal to, you know how to solve this. So finally you will get V is equal to 14.7. So we are writing along the slope up. So this is along the slope up, positive. This is negative mg sin alpha because along the slope down. Then acceleration is negative, I already explained, because it's a deceleration. Okay, question number 2 on vectors. A particle of mass 0.5 kilogram is moving with velocity 5I plus 3j. So the velocity is given 5I plus 3j. That means the component of the velocity along I direction. Unit vector I is taken along the positive x direction with the, that is 5. Positive vector j is taken along positive y direction, that is 3, the component. Right. The particle receives an impulse of negative I, minus I plus j. So the impulse is given I is equal to minus 2I plus lambda j plus lambda j Newton second. This is meter per second. Yeah, u is equal to meter per second. I'll write again. That's meter per second. Okay, then where lambda is a constant. Immediately after receiving the impulse, the velocity of p is xi plus yj meter per second. So that is final velocity becomes xi plus yj meter per second. The kinetic energy gained by p as a result of receiving the impulse is 22 joules. So that means kinetic energy gain means final kinetic energy minus initial kinetic energy. That is, I can say change in kinetic delta K. Delta K means change in kinetic energy. So it's gaining. Gaining means final minus initial. That is 22 joules. question, find the value of lambda. Okay, so before doing it, you should know certain things related to vectors. First, you should know if there's a vector r is equal to just a vector ai plus bj. How to find the modulus, so the magnitude of that vector is equal to square root of a squared plus b squared. Okay, then how to find the direction of this vector? Tan theta is equal to b over a. Remember these things. Tan theta is equal to b over. So what's the meaning of this r vector r equal to ai plus bj? Means if you think about the Cartesian coordinate, this is I, this is j. In the direction of positive I, it has a units. The direction of positive j, it has b units. So a, b means this is the actual vector. So this is the vector r. This is the vector. So how to find the length of this? You know, vector could be shown by a straight line with an arrow. The length indicates the magnitude. So in this right angle triangle, this length is A, this length is B. How to find this length? That's the length is the magnitude of the vector. So what's the magnitude of the vector? The length of r, that is Pythagoras theorem, square root of a squared plus b squared. This is the direction theta, tan theta in this right angle. The height, this b over a. That's all. You must know that. Okay. Other than that, you should know about two vectors if they are saying vector a is equal to vector b. What do you mean by that? Vector a equal to vector b means they are parallel vector and equivalent vector. They have the same magnitude, they have the same direction. Say for example, if they say a is equal to x1i plus y1j and b is given as x2i plus y2j. So what do you mean by that? I component should be the same. That is x1 equal to x2, y1 is equal to y2. You must know these things. Also, for example, when a particle moves, it will have a velocity, its position will change. If the position vector is given as r equal ai plus bj, this is the position vector of the particle. A and b could be function in terms of time, doesn't matter. Yeah. So if you want to find the velocity vector of that same particle, this is the position vector given like this. How to find the velocity vector? Differentiate it. Velocity vector is equal to differentiate their position vector with respect to t, time. So dr over dt is the velocity vector. Say for example, if a is given as a is equal to given as 2t squared plus 5t, b is given as 3t cube plus 4t, something like that. Okay, so you can differentiate. If you differentiate the velocity, how to get the velocity vector? V is equal to, so we'll write the r first. R is given as, r is equal to 2t squared plus 5t I plus 3t cube plus 4t j. So the velocity is given by dr over dt. Then that will be 4t plus 5 I plus 9t squared plus 4 j. That's the velocity vector. Now if you want to find the magnitude of the velocity at a particular time, say for example at t equal 3 seconds, how to find the magnitude of the velocity? First, you know, if you have to find the velocity, magnitude of the velocity. So that is given by square root of 4t plus 5 all things squared plus 9t squared plus 4 all things squared. And if you want to find the velocity at, for example, when t equal 3 seconds, substitute 3, you will get the magnitude of the vector, magnitude of the velocity. So if they want to find the direction of the velocity, tan theta, direction of the velocity, tan theta is equal to j component 9t squared plus 4t, the direction of the velocity at time t equal 3 seconds means tan theta equal 9t squared plus 4 over 4t plus 5. Then substitute the value of 3 there, then take inverse tan, you will get the angle. So substitute t equal 3, you will get the angle in terms of numbers. So t equal 3 means 9 into 3 squared plus 4 over 4 into something like that, you will get a value. Then take the inverse tan, you will get the angle theta. Okay, if you want to find the acceleration vector, then what should we do? We should differentiate again the velocity vector. So velocity vector is given like this. Velocity vector is 4t plus 5i 9t square plus 4j. So differentiate this again with respect to time, you will get the acceleration vector. Okay, so that's not a thing, the same thing. When you differentiate the velocity vector, you will get acceleration vector. If you want to find the magnitude of the acceleration, same thing, square root of compound of the ice. I'll do it again. Say acceleration is given by dv over dt. So if you differentiate this, it's going to be 4, this is 0, 4i plus 18 t j. So this is the acceleration. So here also, if you want to find the magnitude of the acceleration, square root of 4 squared plus 18t whole thing squared, square root of it. If you want to find the acceleration at a particular time, substitute the given time, you will get the acceleration. The direction of the acceleration, if they ask, tan theta is equal to 18t over 4. And if you want to find the direction of the acceleration at a particular time, substitute the value of the time they are giving, find the angle theta by using tan inverse, you will get the angle. Okay. Okay, also you must know this also. Say for example, a velocity vector is given as ui plus u1i plus u2j. This is the velocity vector. Now they can give separately the directional vector of the velocity. Directional vector of the velocity, the direction of the velocity or directional vector of the velocity could be given as ai plus bj. So they might ask to find something unknown thing. So from this we know how to find the magnitude. So from this we know the direction, tan theta is equal to u2 over u1. But the directional vector is given like this. So from this same direction, both this is the directional vector of the velocity. So here also it must be tan theta equal v over a. So when you compare these two, u2 over u1 must be equal to v over a. From this you can find the unknown thing. Okay, so we'll come back to this question. So they asked to find the lambda. So we know the impulse minus 2i lambda j. So we know that impulse I is equal to mv minus mu. We know that impulse vector is given minus 2i plus lambda j is the impulse vector which is given. mv, so if you multiply m, that is 0.5, mass is given as 0.5, so 0.5, v is xi plus yj, mv minus mu, 0.5 into u, that is 5i plus 3j. You can put line for vector, no problem. Even without line, okay, no problem. It's not an issue. Sometimes print books, they make it dark, bold. We can write, when you write, better to put the line, so that indicates unit vector, right? Okay. So we'll arrange it because I told that this vector is equal to the whole vector. So we'll rearrange it. So 0.5 xi minus 0.5 into I. So we'll solve that. It will become we'll multiply 0.5 means, you know, fraction, it's half, so we'll multiply the whole equation by 2. That's easy to avoid decimals. So it will become minus 4i plus 2 lambda j is equal to, so we multiplied by 2 the whole equation, so the 0.5 gone. So xi minus 5j, xi minus 5 minus 5i, so x minus 5i. Then y minus 3j. Check it. 0.5 gone because we multiply the whole equation by 2. So xi here 5y, so x minus 5y, y minus 3j. Okay, so that means x minus 5i, x minus 5 must be equal to minus 4. So that means x minus 5 must be equal to minus 4. From this, x equal 1. Same way, y minus 3 must be equal to 2 lambda. So y is equal to 2 lambda plus 3. Okay, so we got the values of x and y, but x is a number, y is in terms of constant lambda. Okay, so now we are going to use this idea. So we know the velocity v, so therefore if I substitute x and y, so from this I can say, well, final velocity v is equal to, they are giving xi plus yj. So xi, x is 1, so that's going to be I plus yj, y is 2 lambda plus 3j. This is the velocity vector after impulse is applied, because I substitute the x and y in this final velocity. So I showed the v, I removed x and y, and I substitute the values of x, which is 1, and y is 2 lambda plus 3. Now we know the kinetic energy gained by the particle is 22 joules due to impulse, means final kinetic energy half m v squared minus half m u squared is equal to 22 joules. Half m v squared minus half m u squared is equal to 22 joules. So half m is 0.5. V squared means magnitude of this one, so you know how to find it. So V is equal to I plus 2 lambda j, means you know magnitude is 1 squared plus 2 lambda plus 3 squared. Is it? That is the magnitude of V. So V is given as, again I am writing, V is given as I plus 2 lambda plus 3j. That is AI plus BJ format. So magnitude is given by, normally magnitude is given by square root of a squared plus b squared. So here we want the square of the magnitude. So magnitude of V is given by square root of 1 squared, that is 1 plus 2 lambda plus 3 all things squared. That is magnitude. But here V squared means when we square this one, the square root will be removed, so it becomes 0.5 into 1 plus 2 lambda plus 3 all things squared. Okay, so that is half m v squared minus half m 0.5 u squared. U squared is 5 squared plus 3 squared is equal to 22 joules. Okay, this is half. 0.5 means half, so there will be 1/4. Here also 1/4. You will multiply the whole equation by 4. You will get 1 plus. If you expand this one, it will become 4 lambda squared plus 12 lambda plus 9 minus here 25 plus 9, 25 plus 9, and we multiply the whole equation by 4, because here half 0.5 means again half, so 1/4. So we multiply by whole equation by 4, it will become 88. So you'll end up with 4 lambda squared plus 12 lambda minus so this 88 comes left, so minus 88, so here 9 plus 110, here minus 34, this is minus 88, solve it, you'll get minus 1 to 112 equal to 0. So divide the whole equation by 4, lambda squared plus 3 lambda minus 28 equal to 0. You can factorize it. This one lambda squared plus 7 lambda minus 4 lambda minus 28 equals 0. So factorize it. You'll get 7 plus lambda plus 7 into lambda minus 4 equals 0. So from this, lambda is equal to either 4 or and minus 7. So they asked to find the values of lambda. These are the two values, 4 and minus 7. Okay, question number 3. This diagram is given. This portion is shaded. Okay, so this portion is shaded. So this lamina is made by removing a triangle BCD from the rectangle ABDE. So from that, this triangle is removed. So the remaining portion is the lamina. We need to find the center of mass of the lamina ABCDE from the line AE. Okay, so same theory, sigma mi xi over sigma mi is the center of mass from a particular line. You know that sigma mi xi over sigma mi is the center of mass from a particular line or point. So that means if you cross multiply x bar into sigma mi means total mass of the lamina is equal to sigma mi xi. So here the idea I am going to take like this. We know the center of mass of the initial rectangle ABDE when the whole thing is as a solid without removing the triangle BCDE. So the center of mass of this rectangle we know that will be at a distance of 4a from the line A because it will be at the center. Is it? Because it's a uniform rectangle. So the distance of the center of mass from AE will be at distance 4a from AE. So we can imagine this rectangle ABDE is made of two different parts. They are the lamina ABCDE and the triangle BCD. Okay, so we are assuming like that. So I know the center of mass of the rectangle ABD. So they are actually, this x bar is the center of mass of the rectangle, into mass of the rectangle. Mass of the rectangle we can say M, capital M. We'll make it as capital M is the mass of the rectangle. That is equal to sigma mi xi. So we know that the center of mass of the rectangle, we know that at a distance of 4a from AE. Mass of the rectangle also we can find 8a into 6a into mass per unit area. We take it rho, right? So that is equal to, that is this part. That is this part. So this part is this one, I wrote it, is equal to the sigma mi xi. So I can imagine this rectangle is made of two parts. What are they? A, B, C, D, E, the lamina, but they are asking to find the center of mass of the lamina. So its mass we need to find it. So the mass of the lamina M1 we are going to find it. Mass of the lamina we are going to find. How do we find? Total mass of the rectangle minus mass of the triangle is the mass of the lamina. So M1 into center of mass of the lamina we don't know. That's the question. Center of mass, the distance of the center of mass of the lamina from AE we don't know. We are going to find it. Let it be XL lamina, XL. We are going to find it. This we know. The x bar we know that. Plus, then mass of the triangle BCD we can find it. Half into base into height into that is the mass per unit area. So let it be M2 into its center of mass from AE. We can find it because we know the distance of center of mass of the triangle BCD from the vertex will be 2 by 3 of median. So the median will be equal to 6a. So 2/3 of 6a, that is 2/3 of 6a, that will be equal to 4a from C. So from A we need to find it. So the distance, this is 8a, this is 6a, means this is 2a. 2a plus 4a, 6a from A we can find it. So F2 into the distance of the center of mass of the triangle BCD from A. It's not a problem, we can find it. Actually it's going to be 2/3 of 6a plus 2a. This length is 2a. So that's going to be 6a. Okay, so we know the mass of the rectangle. We know the distance of center of mass of the rectangle ABDE from AE. So we know this portion. We know the M1. We can find the M1. M1 is the mass of the lamina ABCDE lamina. We can find it. Total mass of the rectangle minus mass of the triangle. That is M1. That we can find. We are going to find this one. This is the question. We are going to find it. M2 mass of the triangle. Distance of the center of mass of the triangle from A, we know that. So from this we can find the XL. That is, we have to show 14 by 5A. That's the thing we are going to do now. Okay, so we'll find mass of the rectangle. Mass of A, B, D, E. That is going to be 8A into 6A, 8A times 6a into rho, where rho is the mass per unit area. So that's going to be 48 a square rho, that is capital M. Okay, then mass of the triangle we will find it. Mass of BCD, that is M2, I used it here, so I'll follow the same. M2 is equal to we need to find the area, mass of the triangle BCD. So half into base 6a into height 6a. So it's going to be 18a squared. Rho is the mass per unit area. Anyway, it will get cancelled finally. Okay, then we need to find the mass of the lamina. Mass of the lamina, that's a question. The center of mass of the lamina, A, B, C, D, E, we need to find it. So mass of that lamina, mass of A, B, C, D, E, that is M1, we used it when I explained. So I will follow the same, that M1 is equal to the total mass, 48 A squared rho minus 18 A squared rho. So that is going to be 30 A squared rho. That is the M1. Okay, so we use the basic theory or basic principle related to center of mass, that is x bar or M into x bar is equal to M1 x lamina, we are not going to find for the lamina, plus M2 x2, right? M into x bar, M we know mass of the rectangle 48 A squared rho, x bar from AE. So all x bar, XL, x2 are measured from the line AE. That's a question. They asked to find the center of mass from AE. So the center of mass of AB, DE from AE at the midpoint, so that will be at 4A. That will be at 4A. That is equal to M1, mass of the lamina, that is 30A squared rho, into XL, we need to find the center of mass of the lamina from AE, plus M2 is 18A squared into the center of mass of the triangle. For the triangle, the center of mass will be at 1/3 of the median from the base, or 2/3 of the median from the vertex. So 2/3 of 6A, 2/3 of 6A. So from here at 6A, 2/3 of 6A. Then from here, this is 8A. This is 6A, means this is 2A. From here to here, 2A is it. This is 2A. So 2A plus 2/3 of 6A. So plus 2A. That's 8A anyway. Anyway, that's going to be 4A. 2/3 of 6a plus 2a is 4a. Right, we'll solve it. So all the row will get cancelled. All the a squared will get cancelled. We'll solve it carefully and get the Excel. So when we solve, we will get here it will become, so we'll solve 4, a row will get cancelled, 18, 30, 60. So I think we can divide whole equation by 6. Yes, 6 if I divide. 8, 18 to 4, that is 32 will be there. Is it? Sorry, that's not an issue, that one. It's going to be 18a squared. First we'll divide by 6a squared. So this is going to be 8 into 4, 32a, row will get cancelled, is equal to 5 times Excel plus I'm dividing by 6a squared. So 6a squared row. So there is a row missing here. This a squared row is there. So 6a squared row I'm dividing. So that will going to be 3 into here 4a. So 12a. Okay, so that's going to be 5 Excel is going to be 5 Excel is equal to 32 minus 12. That will be check it. It will be 18a. Okay, now correct. So 5 Excel is equal to 32a minus 18a. So that's going to be 14a. So Excel will be equal to 14 over 5a. Nothing, just normal. Carefully if we solve it, that's right. 14, sorry, not 15, 14. Okay, now B part, so that's correct, over. That is more than 14 by 5 means it's more than 2a. So it will be more than 2a means this is 2a. So it will be somewhere here inside the triangle, along the median, median of the triangle, somewhere here, more than 2a, because 14 by 5 is more than 2. So it will be somewhere here. Right, anyway, we need that point. For the second part, the template is freely suspended from A and hangs in equilibrium with AB at an angle theta to the downward vertical. Find the theta, giving the answer to the nearest whole number. So we know that O-level physics, IGCSE, you learned that if you have a lamina and when you hang it, even if it is a non-uniform lamina or non-uniform solid, when you hang it, what happens? The center of mass will become exactly vertically below the point from where the object is hung. Say for example, if this is the object, something, a random shape object, this is the center of mass G, and you are hanging it from the point P. You are hanging it freely from point P. What will happen? The weight will act at point G. If the center of mass is at G, means the weight of the object or lamina will act at that point. So when you hang it at P freely, due to this weight, there will be a clockwise moment until the point G becomes exactly below, something like this. Something like this. So the G, until the point G comes exactly below, it will rotate. It will rotate until the point G becomes exactly below. Is it? Then there is no turning effect due to the weight, because the line of action of the weight is passing through the point P about which the lamina is hung. So there is no turning effect. Turning effect will become 0. So it will be at equilibrium rest. Okay. So here what they are saying, now they are going to hang this by using point A. From point A, the lamina is hung. Yeah, that's what they said. The template is freely suspended from A. Right. So if it is suspended from A, what's going to happen? The center of mass from AE will be along this line because due to the symmetrical shape, it will be along this line. So it will be at a distance from AE at a distance 14 by 5 means it will more than 2a. So it will be somewhere here. So when we hang it, this point, center of mass G, will become exactly below A, and it will rotate until the G becomes below A. And they asked to find the angle between the line AB, and the vertical. So vertical means this is going to be the vertical. Now when it is hung, the line AG will be in vertical because G will be exactly below A. So the line AG will become vertical. This line AG will be exactly vertical. G will become exactly vertically below A. So the question is to find the angle between AB and the vertical line when it is suspended from A, means we need to find the angle between this line and AB. This angle we need to find it. Okay, it's not an issue. So we'll think about this right angle triangle, this right angle triangle, this G, this point is G. We'll name this point, we can name this point P. So now we'll consider the right angle triangle, B part. We'll consider the right angle triangle, APG. This angle, let it be alpha. This angle is 90. So if I find alpha, 90 minus alpha is the theta. We need to find the theta, that is 90 minus alpha. So we need to find the alpha. How can we find the alpha? In this right angle triangle, we know this AP, the length AP is equal to 3A, half of, because it's a midpoint, half of 6A. PG we know 14 over 5. So tan alpha is equal to PG. PG is 14 over 5A divided by AP, this length, that is 3A. So that will be 14 over 15. So alpha will be tan inverse 14 over 15. That's going to be 43 degree. Tan inverse 14 over 15 will be equal to 43 degree. But we need to find the theta. So theta is going to be 90 minus alpha. So from the theta will be 90 minus 43. That will be 47 degree. That's the answer. So the angle of line AB with the vertical is 47 degree. Vertical means the line AG. Okay, question number 4. Again, it's on vectors. So I already explained the theory that you should know related to M2, mechanics M2. In question 2, when I discussed the question 2, I already explained the required theories that you should know. So you can go through it again. So we'll go to the question 4 now. A particle Q of mass 1.5 kilogram is moving on a smooth horizontal plane under the action of a single force, capital F newtons. At time t seconds, the position vector of Q relative to a fixed point O is symbol R meters, and the velocity of Q is V meter per second. It is given that V equal, they are giving a velocity V in terms of unit vectors ing. Okay, I'll put those things on the board. So that means the mass of the particle is 1.5 kilogram. And there is a force F Newton is acting on it. At time t equals 0, the position vector Q relative to a fixed point O, R is given by, R is not given, is denoted by R, but the speed velocity V vector, is given by 3t squared plus 2t I plus tq plus ktj. So this is the velocity vector. If you differentiate, you will get the acceleration vector. If you integrate this, you will get the dr over dt. dr over dt is the v. So if you integrate velocity vector, you will get the position vector. You know that the reverse process, right? Okay. Anyway, we need these things in the question. Where k is a constant, given that t equal to, when time t equal to, the particle q is moving in the direction of I plus j. Okay, now look at it. What's the meaning of it? Now, a particle's direction of motion of a particle is always along the direction of the velocity. A particle can't have motion towards north and the velocity towards it. Always direction of motion and the direction of velocity are the same. So here they are saying at time t equal to, particle q is moving in the direction of vector I plus j, means that's a directional vector of the velocity at time t equal to is given as I plus j. Okay, so we know, so the A part, we know that velocity v is given by 3t squared plus 2ti t cube plus ktj. So I already told that if there is a vector A is equal to xi plus yj, the direction of this vector is tan inverse y over j, or tan theta equal y over x is the direction. At the same time, they are telling the direction of v, that is separately given it as I plus j. So I plus j means 1 here 1. So if I take a tan theta here, tan inverse 1 over 1, that is tan inverse 1, 45 degree. So the particle is moving, the velocity is at 45 degree with the positive I direction, that is along from the x-axis, I direction, unit vector I, is moving at 45 degree because tan inverse 1 over 1 is tan inverse 1, tan inverse 1 means 45 degree. So if I find the direction, so that means tan theta is equal to t cube plus kt over 3t squared plus 2t is equal to here 1 over 1. 1 over 1. So when t equal to, they are saying this is 1 over 1 when t equal to, so substitute 2, so that is 2 cube plus k into 2 over 3 into 2 squared plus 2 into 2 equal 1. Okay, solve it and find the k from here. So that's going to be, how much is it? This is going to be 4 plus 3, 12, 12 plus 4, 16, is it? It's going to be 16 here. This is going to be 8 plus 2k. So that means 8 plus 2k cross multiply. This is 4 into 3, 12, 12 plus 4, 16. So k is going to be 16 minus 8, that is 8 divided by 2, 4. That's the answer. That's the answer for first part, k equal 4. Okay, B part. Find the magnitude of force F when t equal to. So there's a force, the particles under action of a force F. We can use F equal ma, but we need to find the A first. Then F equal ma. Then at time t equal 2 seconds, we need to find the force, means we'll find the acceleration first. That will be a acceleration vector. Substitute t equal 2 in the acceleration vector. Then find the magnitude of the acceleration vector. Then F equal ma, we know the mass, we can find the F, just nothing. So first we'll find the acceleration. So B part, we know the velocity vector, that is 3t squared plus 2t I plus t cube plus k, we know now 4t. So acceleration is equal to dv over dt, the acceleration vector. So differentiate it. So it's going to be 6t plus 2I plus 3t squared plus 4j. This acceleration vector. Okay, so at time t equal to, the acceleration vector will become, we will substitute 2, 12 plus 2, 14I plus 4, 2 squared 4, 4 into 3, 12, 16j. That's the acceleration vector. Okay, so we can use F equal ma. We can find the force vector if you want. We'll find the force vector first. Then F equal ma. So mass we know that is given 1.5 kilogram. So 1.5 into 14I plus 16J. So it's going to be 21I plus 24J. We need to find the G at t equal 2 seconds. So everything we are finding at t equal 2 seconds because we already found 2 seconds, is it? So we need to find the force, modulus of force, square root of 21 square plus 24 square of square root. Okay, sorry, 21 square plus 24 square, you'll get 3 square root of 113. You can solve it and give decimal, but this is correct, is it? This is a force vector. What I found here is the force vector at time t equal 2 seconds. This is the magnitude of force at time 2 seconds. 2 seconds. So it will be different at different time because force vector depends on okay, and it's a constant force because it does not depend on time anyway. So it's going to be a force vector. Yes, 1 minute. The acceleration, yes, depends on time. So force depends on time. So what we are finding is at 2 seconds. Yes. So force will be different because acceleration depends on time. Acceleration depends on time. So force will be depends on time. Different time, the force will be different because acceleration depends on t. So force also depends on t. But from here I substituted 2 seconds for the acceleration. So I found the acceleration vector at 2 seconds. Then I found the force vector at 2 seconds. So force vector will be different at different time because acceleration vector depends on time t. Okay, now part C part. They are saying given that R, the position vector, R equal 3I plus 4J when t equals 0. So initially when t equals 0, its position vector is given, which is 3I plus 4J. Find R, that is position vector when t equal 2. Okay, now how to find the position vector? We know the velocity vector is given in the question. Velocity vector, it's a time dependent velocity vector which depends on time. You know, when you differentiate velocity vector, you will get acceleration vector. If you integrate velocity vector, you will get position vector because velocity is given by dr over dt. Differentiation of velocity vector is the, differentiation of position vector is the velocity vector. So if you integrate, dr is equal to integrate v dt. So if you integrate the velocity vector, you will get the position vector. So we will integrate the given velocity vector. So that is, we know that dr over dt is equal to, that is the velocity vector which is given by this one is the velocity vector, that is 3t squared plus 2t I plus t cube plus k already we found it 4, so that is 4 t j. So integral of dr, I am going to get r on the left side, is equal to integral of 3t squared plus 2t I plus t cube plus 4t j all the into the integral dt. I'll put separately I and j together. So integral of 3t squared plus 2t I dt plus integral of t cube plus 4t j integral. Okay, so when we integrate, there will be a constant. That constant should be given or substituted for I vector and j, I and j separately, because I and j are independent vectors among them. They are not depending on each other. So we have to put separate constant for I and j separately. Okay, now we'll do the integration. So left side integral of dr is r vector. We are going to get position vector which is time dependent. When we integrate it, it's going to be 3t cube over 3. When you integrate t squared, it will be t cube over 3. That 3 and this 3 will get cancelled. So t cube plus 2t, integral of 2t, that is t squared by 2. That 2 and this 2 will get cancelled. t square plus constant c1 I plus now t cube integral, it will be t to the power 4 over 4 plus 4t squared by 2, that 2 and this 4 will get cancelled, so 2t squared plus c2 j. So this is the general equation for the position vector in terms of time. So it's a time dependent position vector, but it's given that when t equals 0, they are saying it, when t equals 0, the position vector is given as 3i plus 4j. It's given there. Position vector is 3i plus 4j when t equals 0. So when we substitute t equals 0, this one should be same as this one. So we'll substitute here. Therefore, r is equal to, I'm substitute here 0 plus 0. When I put t equals 0, both will become 0. c1i plus 0, 0. When I put t equals 0 plus c2j is equal to 3i plus 4j. So I already explained, if there are two vectors equal, c1 must be equal to 3, c2 must be equal to 4. So c1 equal 3, c2 equal 4. So position vector, the general position vector, time dependent position vector is given by r is equal to t cube plus t squared, t cube plus t squared plus c1. c1 is 3 I plus t to the power 4 over 4 plus 2t squared plus c2 4. So this is the time dependent position vector. So by using this time dependent position vector, I can find the position vector at any time. Now the question is, we need to find the position vector when t equals 2. So when t equal 2 means 2 seconds, then if the unit t equal 2, the position vector is going to substitute 2 there. So 2 to the power 3 plus 2 squared plus 3i plus 2 to the power 4 over 4 plus 2 into 2 squared plus 4j. Solve it, you will get the position vector at time t equal 2. So that is 8, 4, 12 plus 3, 59 plus this is 16 divided by 4. 16 divided by 4 is 4. Then this is going to be 4 plus 4, 8. Then that will be 8 plus, 8 plus 8, 16. Yes. Yes, 16j. So this is the position vector when t equal 2 seconds. Easy, is it? Okay, question number 5. This diagram is given. A rough straight ram is fixed to horizontal ground. The ram is inclined at an angle theta to the horizontal, where tan theta equal 5 by 12. So we can find cos and tan. So tan theta equal 5 by 12, 5 over 12. So this is going to be square root of 13, because 12 squared 144, 5 squared 25. So it's going to be take the square root, it will become 13. So we can find all sine, cos, tan also. Okay, so the points A and B are on the line of greatest slope of the ram, with AB 2.5, A to B 2.5 meters and B above A. A package of mass 1.5 kilogram is projected up the ram from A with a speed u meter per second, and first comes to instantaneous rest at B. So it's a rough ram. Rough ram means there will be friction. When it moves, the friction acting on it will be the limiting friction, because it's in motion. So limiting friction is given by F equal mu r. So find how to find the r. Already I explained that during my first question when I discussed, and I'll tell it again. If the angle is theta, and if you keep an object on a slope, the weight will act vertically down, mg, This angle will be 90 minus alpha. This is 90, so 90 minus alpha. The component of the weight perpendicular to the slope, this component of the weight perpendicular to the slope will be mg sine 90 minus alpha, that is mg cos alpha. And the component of the weight along the slope down will be mg cos, this is 90 minus alpha, I already told, mg cos 90 minus alpha, so that will be mg sine alpha. The normal reaction will be perpendicular to the slope. Now look at here. So this mg I can remove because I have already components are found in two right angle directions. So now the particle is moving up or down along the slope, means there is no motion perpendicular to the slope. So when there is no motion perpendicular to the slope, means the resultant force perpendicular to the slope must be equal to 0. When you consider along this direction perpendicular to the slope, this is the way we normally show perpendicular to the slope, when we consider r minus mg cos alpha equal to 0. So r will be equal to mg cos alpha. The friction, limiting friction is equal to, when it is in motion, the friction will be limiting friction, not it's in motion, so the friction will be the maximum, F equal mu r. So the limiting friction will be given as mu r, that is mg cos alpha. So I'm going to use all these things. So sorry, cos theta, is it? I'm using theta here. So cos theta. So I'm going to use this one in this question. Okay, and remember that when you resolve the weight along the plane down, mg sine theta. So anyway, it is theta. So mg sine theta, and perpendicular to the slope, it will be mg cos theta. Along the slope, mg sine theta, perpendicular to the slope, cos theta. Remember that. And the friction, limiting friction, if equal mu r, so mu mg cos theta. Right. So I'm going to use these things in this question. So in this question, they are giving tan theta 5 by 12. Then AB 2.5 meters, mass is 1.5 kilogram, coefficient friction 102 by 7. Okay, the package is modeled as a particle, so it comes to rest, it's projected at u meter per second and first comes to instantaneous rest at B. Find the work done against friction as the package moves from A to B. So nothing, you need to find the friction, F equal mu r, r equal mg cos theta, just how I explained, because it's a limiting friction. So find the friction, then use work done against friction. Work done against friction means friction into distance moved opposite to the friction, opposite to the direction of friction. So A part, we'll find the friction force, Fr is equal to mu r, r is equal to mg cos theta. So Fr is equal to mu mg cos theta, right? So we know the tan theta, so from that we can find the sin and cos theta. So work done against friction, work against friction equal friction force into distance moved opposite to the direction of friction. Opposite to the direction of friction is the distance moved. So that we can say work against friction, we'll say WFR, work against friction. I just use the notation. It's not a standard notation, just I'm using it. Okay, the friction force mu mg cos theta into d. So mu is given 2 by 7, mass is given 1.5, 9.8, cos theta, that is 12 over 13 into distance moved 2.5 joules. So that will be 9.69. 9.69 joules. Okay, big part. Now big part, use the work energy principle to find the U, work energy principle. So that means it was projected, just thrown. So when it moves from A to B, what energy changes occurs? When it moves along the line, along the slope, it's losing the kinetic energy. That's only one type of energy loss. It's loss in kinetic energy equal to gain in gravitational potential energy, because height is increasing and there is work done against friction. Work done against friction is because of losing the kinetic energy. Otherwise, it can't do work against friction. So normally, practically, the work done against friction is the outcome is sound and heat in physics students. Not you don't need math students. So anyway, loss in kinetic energy equal to gain in gravitational potential energy plus work done against friction. So from that you can find the U. So B part, loss in kinetic energy equal gain in GPE, gravitational potential energy, plus work against friction. Okay, so loss in kinetic energy, initial kinetic energy, half mu squared minus half mv squared, anyway v is 0, they are telling it. Gain in GP, mgh. So how much is h? From A to B, this height is, h is, this h is equal to, in this right angle triangle, 2.5 sine theta. Is it in this right angle triangle? This h is 2.5 sine theta. This is theta, this is also theta, parallel angle. Okay, mgh, we will substitute it. Mgh, h equal 2.5 sine theta plus work done against friction, we found it 9.69 joules. Okay, we'll put this unit finally. H equal, so I'll put h equal 2.5 sine theta. I want to substitute that. Okay, so V0 half, the mass is 1.5, u squared minus 0 is equal to, mass is 1.5 into 9.8, h means 2.5, sine theta equal 5 over 30 plus 9.6. Okay, solve it and find the u. Take the square root. You will get u is equal to u will be equal to 5.64. That's the initial speed, 5.64 meter per second. Now C part, use after coming to instantaneous rest at B. So now it has reached the point B now. So it has reached the point B where the speed becomes 0. After reaching point B, instantaneous 0, the package slides back down the slope. Use work energy principle. Again, they ask you to work energy. So you can't use Newton's second law, but you can use, you will get the same answer, but here it's restricted. Only thing you have to use work energy. So you have to follow that question. So use work energy principle to find the speed of the package when at the instant it returns to A. So when it reaches, so it's moving down now from rest. When it reaches the point A, what will be its speed? That's the question. Okay, when it moves down, again we have to use the energy equation. The friction will be the same friction, nothing different, because it's moving on the same slope, same normal reaction, nothing changed. So when it moves down, what could be the energy equation? C part, we can say loss in GP is losing the gravitational potential. It is going down, so it's losing the gravitational potential. Loss in GP equal to gain in kinetic energy, speed is going to increase, plus work done against friction. So loss in GP equal gain in kinetic energy plus work done against friction. So work against friction is the same answer. I don't need to do it again. Same answer as we got earlier. So loss in GP, mgh, same h, mgh, same height is going to move from B to A, same height mgh equal gain in kinetic energy. Gain in kinetic energy is half mv squared, final kinetic energy minus initial kinetic energy. Initial kinetic energy 0 because moving from rest, it came to rest at B. Now it's moving down. Work done against friction, the same thing what we got earlier, 9.69 joules. Okay, so M, that is 1.5, 9.8, H is 2.5, sine theta, 5 over 30, half The mass is 1.5 V squared minus 0. Is it because initially it was at rest at V plus 9.69. Solve it and find the V. That's a speed at A when it returns 2.43 meter per second. Nothing. We have to identify the energy changes or conservation of energy. What is lost, what is gained. So total loss equal to total gain. So simply that means the work against friction means because of losing the in this motion, because losing the GPA, that loss in GPA is converted to what format? GP is converted to gaining kinetic energy and to do work against friction. So that's the reason we write loss in GP equal gaining KE plus working against friction. Identify the conservation forces. What type of energy is what type of energy interchange happens that you have to identify. Okay, this diagram is given for question 6. A uniform pole AB of weight 50 Newton. So uniform means it will act at the center. 50 Newton and length 6 meter has a particle of weight W, that is the particle B, newtons attached at B. The pole has its end A freely hinged to a vertical wall. A light rod holds the particle and the pole in equilibrium, the pole at angle 60 degree to the wall. One end of the light rod is attached to the pole at C. One end is here C. Attached to the rod at C, where AC is equal to 4 meters. The other end of the light rod is attached to the wall at point D. The point D is vertically below A and AD 4 meters. The pole and the light rod lie in a vertical plane which is perpendicular to the wall. The pole is modeled as a rod. Given that thrust in the weight in the light rod is 60 root 3 Newton. So that means due to the weight of the pole AB and the particle which is kept at end B, the rod is hinged, so it can rotate. The AB can rotate about the hinge either up or down, something like this. It can rotate like this, up or down. So what will happen? So there's a light rod is kept at here, which is going to give a compressive force on it. So when it gives a compressive force, when the rod AB compress DC, DC will exert a force on it according to Newton's third law along the same line on AB. So we can show the first part. The pole and the light rod lie in a vertical plane. Given that the thrust in the rod is 60 root 3 Newton, show that W is equal to 15. Okay, so that means first part is simple. We can take moments about A, but we'll show the forces acting on it. So I'll draw it again. The forces acting on the rod AB or the pole AB. So if I draw the pole AB parallel line, if I draw AB like this, AB. So there will be force acting on the hinge. We don't know what's the direction, whether up or down or whatever it is. The forces acting on A could be shown in two right angle components. Those two forces are unknown. Anyway, we don't need that now because I'm going to take moment about A. The advantage of taking moment about a point where there are unknown forces, those forces won't be included in our equation. The question is about the W, so easy to take moment about A. So the weight at B, the weight of the particles, so the particle which is kept at B will push the pole at B downwards, so there will be a push by the weight W downwards, that is W. It's a uniform rod, so there will be a weight of the AB at center, so the weight of the pole AB, that is 50 Newton, that will act at the center, 50 Newton. And the light rod DC has a thrust 60, given that a thrust in the light rod is 60 root 3. So that means the pole AB will compress the light rod DC. So the compressive force exerted by AB on DC will be along this direction on DC. According to Newton's third law, DC will exert same magnitude of force at C, same magnitude of force at C, this direction, same line, the same line of action, it will exert the same magnitude of force, which is 60 root 3, 60 root 3. So that will be along the same line. Okay. So we know that angle, we can find it, we'll find that angle. Okay, so we will take moment about A. Okay, to when we take moment about A, so that means this force acting on C will be this direction. Exerted on AB on C will be along the same line this way. This is 2 meters. That is 60 root 3. Okay. Now we will take moment about A. When we take moment about A, there will be force at the hinge. We don't know the direction, we don't know anything about it. So we will take moment about A, then that force will not be included in our equation. So the unknown forces won't be included. Means we can have only one unknown force W. We can find it easily. Okay, we'll take moment about A, the A part. For that we should know the moment is defined as force into perpendicular distance to the line of action of force. So the perpendicular distance to the line of action of weight is this one. So we need to find this distance. We need this distance. We can find it. For W, this is the line of action. For W, the line of action, the distance is this one. That also we can find. For this force, we need to find the perpendicular force. The perpendicular distance from A to this force. Okay, that we can find like this. We can resolve this force parallel to the rod, perpendicular to the rod. That's easy. Because if I resolve this force parallel to the AB, means that force, the parallel component, if I resolve it this way and this way, the force this way, this component won't have any moment because that force will pass through A. The line of action of the force after I resolve it parallel to the AB, that will pass through A, so it won't have any perpendicular distance. Say for example, if there's a rod something like this, you are trying to take moment about point A and there is a force on this one, this direction, force F. What is the moment or turning effect of this force about A? 0, because the definition is force into perpendicular distance to the line of action of force. So the line of action of force is passing through A, so there is no perpendicular distance from A to F. But if there is a force perpendicular to the rod, then the distance to this force is this distance. So F into that distance. So we will resolve this one parallel to the pole AB and perpendicular to the pole AB. For that we need this angle, we need to find it. That angle we can find simply because this is 4 meter, this is 4 meter, this is 60 degree. That means this will be 120 degree. Straight line 180. So this is 120 degree. Total angle is 180. The total angle is 180. So 120 means remaining 60 means this is 30. This is 30. Because these two are same length. So this is 30 means this is 30 because opposite angle. So we know this is 30 degree. So we'll resolve this 60 root 3 along the rod AB, perpendicular to the rod AB. This is acting at point C. So if I resolve it along the rod AB, that will 60 root 3 cos 30. 60 root 3 cos 30 will not be included in my moment because that force will pass through A. If you want, you can find this distance also, line of action. This is the line of action. You can find this length also, no problem. Either one you can resolve it parallel, perpendicular, or you can find this is the line of action. This is acting here. Line of action of that force, line of action of this force is this line. You need to find, you are finding the moment about A, you need to find the perpendicular distance, means you have to find this distance. You have to find this distance which is perpendicular to the line BC, this line. So that will be this one. You can find that also if you want. You can find this distance D also. No problem. In this right angle triangle, that is 4 sin 30. You can find D. Either way, it's up to you. You can resolve this force parallel to AB and perpendicular to AB. If you feel that is difficult, directly find the perpendicular distance to the line of action of 60 root 3, which is D. That D is in this right angle triangle. This is 30, this is 4, so it's going to be 4 sin 30. We'll do that way. It's okay, no problem. That we'll find it rather than resolving it parallel and perpendicular. Okay, so now we'll take moment about A. We'll take moment about A. Either way you can do. So I'll do this distance, we'll find it. D is going this distance, that is the perpendicular distance to line of action of 60 root 3 is 4 sine 30. So D is going to be 4 sine 30. So sine 30 is equal to half, that is 2 meters. That is the distance, perpendicular distance to 60 root 3 from D. Okay, we take moment about A. So take moment about A. So this is A part. We'll take moment about A. So the forces at A won't be included. So 50 into this distance we need to find. We'll see this is D1, this is D2. Okay, D we found it. So D1, so what is D1? 50 into D1. So that's clockwise direction. 50 into D1. D1 is, this is center, this is total length is 6 meters. So this is 3 meters. From here to here 3 meters. So this angle we know, the angle with horizontal line, the rod AB that makes an angle with horizontal line, this is 30 degree, this is 60, this is 90 means this is 30 degree. So that is going to be 3 cos 30, 50 into 3 cos 30. That is clockwise moment plus the W weight, the weight W, the distance of the line of action of weight from A, this length, that is W into, this is 6, the total length is 6 cos 30. So the line of action is along W, this one. This length is, this angle is 30, so this angle is 30, AB is making 30 with horizontal. So W into 6 cos 30, that also clockwise moment. Now this 60 root 3 will produce anti-clockwise moment about A. It will produce anti-clockwise moment. So that is minus 60 root 3 into the perpendicular distance to line of action of 60 root 3 from A is this one, D. I already found it. D equal 4 sine 30. That is 2 meters. So that is 2 meters. 4 sine 30. That is 2. Equal to 0. Everything you know except W. Solve it and get the W. You will get 15 Newton. Okay, now B part. Find the magnitude of the resultant force acting on the pole at A. So at the hinge A, what's the resultant force? Okay, they are not asking anything about the direction. So at A, what is the resultant force acting? We don't know what direction, nothing. So we'll imagine the compound of the forces acting on A horizontally F1 and vertically F2. We don't know what are the forces, whether actually is it horizontally towards left or right also, I don't know. I'll take it towards right. I'll do and solve it. If I get negative answer for F1, that is towards left. If I get negative answer for F2, that is towards down. Nothing to worry. We'll take just F1 towards right, F2 vertically upwards. You know, any force could be resolved into two right angle components. So I don't know the actual force. I imagine that could be resolved into two right angle components. The horizontal component is F1 towards right. Vertical component is F2 upwards. I am taking it. Maybe a vertical component is F2 downwards. Doesn't matter. If I get negative answer for F2, that means it's downwards. Okay. Now these are the actual forces acting on the rod. So right to at A, at the pole A, at the end A. At end A, there's a force hinge that I took it towards right component horizontal and vertically F2. Then 50 Newton is the weight of the pole AB, and there's a force that's pushed by the light rod DC 60 to 3 at an angle 30. And there is at B, there's a particle, its weight W. Now we know W, that is 15 Newton. So these are the forces acting on it. So how many forces are there? 1, 2, 3, and resultant of it. 4 forces acting. Okay, now we know the pole AB is at rest under this is B part. Pole A part is this, I have done it. So now B part, so I will erase this one. Since pole AB is at rest, The resultant force in any direction must be 0. Any direction means horizontally it must be equal to 0, vertically it must be equal to 0. So when I resolve all these forces in vertical direction, I should get 0. So I'll resolve all the forces vertically. So F2 upwards, this is 50 downwards minus, this is downwards minus 15. If I resolve it upwards, that means it makes with horizontal line. This is 30 means this is with horizontal line, that is going to be this is 30, so it's going to be 60. This is 30, the rod is making 30, so with horizontal line the force, this one is making 60 degree. So if I resolve it vertically, it's going to be vertically upwards plus 60 root 3 sine 60, because with the rod it makes 30 degree. Rod is making 30 degree with horizontal. So already they are giving this is 60 degree means with vertical. This is 30. So this is with the horizontal. The force is at 60 degree. Okay, so sine 60 must be equal to 0. Okay, solve it and get F2. You will get F2 is equal to minus 25. I am getting. So I took F2 upward direction. I am getting minus. So that means F2, the force, vertical component of the force at A is downwards 25 Newton. Okay. Now horizontally we will resolve it. F1, I took it towards right. F1, this has no horizontal component because it's already a vertical force. Vertical force, no horizontal component. This one will have a horizontal component, that is 60 root 3 cos 30 plus. I took it towards right. So anyway, this is also towards right. Plus 60 root 3 cos 60 equals 0. So we will get F1 is equal to negative 30 root 3. That means F1 is towards left. F1, I'll write it here. F1 is equal to 30 root 3 towards left. I'll write it here. F1 is equal to 30 root 3 towards left. Okay, so I know the components of the forces acting at A. Vertically downwards 25. Vertically downwards 25 Newton. Towards left 30 root 3. So actual force acting at A, I can call it as resultant force Fr. I can find by using Pythagoras theorem because they are perpendicular. So Fr is equal to square root of 30 root 3 all in squared, 25 squared. So that will be 57.7 Newton. So resultant force at A is 57.7 Newton. Nothing is mentioned about the direction, but if you want, you can find the direction. Find tan theta equal opposite to adjacent. You can find the actual direction of the resultant force acting at A also, but that's not a question. They're asking only the magnitude. So it is 57.7 Newton. Okay, question number 7, that's based on momentum. A particle P has mass 3m and particle Q has mass km. The particles are moving in towards each other on the same straight line on a smooth horizontal surface. Particles collide directly, head-on collision. Immediately before collision, speed of P is 2u and speed of Q is 3v. Immediately after collision, the speed of P is u and the speed of Q is v. The direction of motion of P is unchanged by the collision. So P has the same direction of motion after collision. Okay, so show that V is equal to 3 minus 3k. Okay, we have to show. So I'll show it on a diagram. So particle P, mass 3m, moving towards right at a speed u. I take it towards right, 2u. This is P. The other one is km. moving towards opposite direction, 3u. This is before collision. After collision, direction of P is the same. So I should draw the direction of P after collision to the right. So its speed is u after collision. This is 3m. So Q also should move towards right, otherwise it can't move to the left when it moves to the right after collision. So that is V to the right, that is Q, Km after collision. Okay, so we need to show that relationship, that is V, by using law of conservation of momentum. So we'll use the law of conservation momentum for A part. We'll use the law of conservation momentum towards right. So that means any velocity towards right will be taken positive. You can use it towards left also, no problem. I'll take it, no reason, just towards right. So that means 3m into 2u minus, this is towards left, so minus km into 3u is equal to again 3m into u plus km into v. So m everywhere will get cancelled. So it will become 6u minus k3 ku is equal to 3u plus kv. Bring it to the left. 6u minus 3u minus 3 ku equal kv. Okay, so 6u minus 3u, 3u minus 3 ku equal kv. So v is equal to 3u, 3 minus 3k u over k. That's the first part. Okay, B part. Find in terms of m and u the magnitude of the impulse received by q in that collision. So you know impulse means force into time, that you had it in IGCSE physics also, I equal ft. At the same time impulse is equal to change in momentum. During collision, what happens when two particles collide, they exert same magnitude of force on each other. Say if P and Q, when they collide, P will exert a force on Q. The same magnitude of force will be exerted on P by Q because Newton's third law. They will experience this force for the same time because when they collide, both will be in contact for the same time. So Ft equal to Ft. Both will experience same magnitude of force for the same time. So therefore they will experience same impulse. The question is, find the impulse experienced by Q. So if you try to do I, also we know that I is equal to mv minus mu. So that mv minus mu is a vector quantity that's in the direction of I is in the direction of force. So for Q, the impulse will be towards right. That means change in momentum of Q is towards right because it experiences force during collision. According to my diagram, Q will experience force towards right, so its impulse will be towards right. Change in momentum also will be towards right. For P, it experiences force during collision towards left according to this diagram. So P will experience force towards left, means impulse will be towards left, change in momentum also towards left. But they will have the same magnitude. Only thing, they have opposite direction, but they'll have the same magnitude. So here they asked to find the impulse experienced by Q. So you might try to do for Q, that is mv minus mu, change in momentum. But the problem here, when you try to do it for Q, K also will appear in your equation, but K is an unknown quantity. That is the next part. Find the range of possible values of Q. So it's an unknown. So question says, find the B part, find in terms of M and U. So you can't include K there. So if you try to find the impulse by using change in momentum of Q, particle Q, you will be in trouble because K will appear in your equation. Final answer. So to avoid it, we'll do it for particle P. change in momentum is equal to impulse. We will use it for particle P. The change in momentum of P is towards left. We'll use it for P and we'll find the magnitude of the impulse of P, but the same magnitude will act on Q in opposite direction. So do it for P because to avoid K in our answer. So we'll do that way. So we'll do it for P. So second B part, for P, we know that impulse I is equal to mv minus mu, that will be towards left because according to this diagram, P will experience impulse towards left during collision, and also it's given the, so I is equal to mv, so mass of the P is 3m, final velocity of P is towards right, but it should be towards left, so I should put minus u, because impulse on P is towards left, final velocity is towards right, so I'm taking towards left this equation, so I should put minus. This minus I should put minus, that minus, mv minus mu, that minus I put it here, again 3m, initial velocity towards right, I'm using towards left, so again minus 2u, solve it, minus 3mu plus 6mu, so it's going to be 3mu. That is the impulse on P. But Q will have the same impulse, same magnitude of impulse, opposite direction. Therefore, impulse on Q also the same 3mu, but in opposite direction. Here I took it towards right, so Q will have the impulse towards right, because both will experience same magnitude of impulse. Okay, part C, the coefficient of restitution between P and Q is E. Given that B is not equal to U, find the range of possible values of K. Okay, we'll find the possible values of K by using Newton's experimental results for impact. So it says that relative speed of separation is equal to E times, E is the coefficient of restitution, E times relative speed of approach. That means speed of separation or relative speed of separation. That happens after collision. After collision, they go away and away because they won't collide again. Approach happens before collision. If they don't approach, they can't have collision. So E times speed of approach. Speed of approach means relative speed of approach. Okay, this is the experimental results done by Newton. It's called Newton's experiment for impact. Okay, E is a quantity we call coefficient of restitution. The value of E, the range less than 1 greater than 0, we can put equal sign also. The reason is, if E equal to 1 means perfectly elastic collision, it will bounce off perfectly with the same speed. Equal to 0 means perfectly inelastic. After collision, it will stick to that. So that is called perfectly inelastic. But in this question, they are nothing related to perfectly elastic or perfectly inelastic. So we can put less than 1 greater than 0. So equal sign is not necessary. Generally, it's less than 1 greater than 0. Okay, we'll do that way. So we'll use that Newton's experimental results for impact. So speed of separation, relative speed of separation means V minus U. V minus U is equal to E times relative speed of approach. They are moving in opposite directions, so that is 3U plus 2U. We know V, we found V for expression in the A part, so that is 3 minus 3K over K into U, minus U is equal to E times 5U. We'll solve it. This is going to be 3U minus 3KU, here minus KU over K is equal to 5EU or E times 5U. So it's going to be 3U uh, minus 4ku, 3u minus 4ku over k equal E times 5u. All the u will get cancelled. So you will get 3 minus 4k over k equal 5. I can bring the 5 dot equal to E. 3 minus 4k over 5k is equal to this 5 I bring it down. So is equal to E. Okay, so we know that E should be less than 0, less than 1, greater than 0. I already explained the reason, less than 1, because if it is 1, perfectly elastic, equal to 0, completely inelastic. So normally, less than 1, greater than 0. So we'll take 1 by 1. So if E greater than 0, we'll take this portion. If E greater than 0, that E should be greater than 0. 3 minus 4k over 5k, 3 minus 4k over 5k, that is E, is it? That is E, must be greater than 0. So that means 3 minus 4k must be greater than 0, 3 must be greater than 4k, that is 4k less than 3 means k less than 3 by 4, is it? Okay, then we'll take E less than 1. When E less than 1, it must be E less than 1. That means 3 minus 4k over 5k should be less than 1. First multiply 3 minus 4k less than 5k. That is 3 less than 9k. That is 9k greater than 3. So k should be greater than 1 over 3. Okay, so what could be the range of k? K should be greater than 1 over 3, less than 3 by 4. That's the range. Final answer they asked to find it. Okay, question number 8 based on projectile motion. A particle P is projected from a fixed point O. The particle is projected with speed u meter per second at an angle alpha above the horizontal. The particle moves freely under gravity at an instant of when the horizontal distance of P from O is x. P is y meters vertically above the level of O. Show that y equal x tan alpha. So it's a normal theory. So we can draw the particle is projected and follows a path something like this. It's a horizontal line. It's projected at an angle alpha. Initial speed is u. When it has a displacement horizontally x towards right, it has a displacement vertically upwards. Vertically upwards, why I am taking it? So the displacement is vertically up. I am taking when the displacement is horizontally towards right. Okay, so we need to show the relationship between horizontal displacement and the vertical displacement. You can see in that equation no time, so I need to eliminate the time. Okay, we'll use the equation s equal ut plus half at squared horizontally. So if I use s equal ut plus half at squared horizontally, I'm using a part. So s is x u cos alpha times t plus 0 horizontally, no acceleration, we know that. No drag force, gravitational acceleration is vertically down, which has no horizontal component. So t is going to be x over u cos alpha. I use vertically upwards. When I use vertically upwards, the displacement up, the vertical component, initial velocity also same direction, because I am telling it specifically because I need this idea for the last part, C part. So here I am taking this derivation, we are taking displacement up, initial vertical velocity, vertical component velocity also up. So S equal ut plus half at squared, I am using upward direction. S is y, which is upward direction. Initial vertical component of velocity is also upward, that is u sine alpha into, instead of time I can substitute x over u cos alpha plus, I am taking upward direction, so minus g because gravitational acceleration is down. I am taking upward positive, so minus g into t square. T square is equal to x squared over u squared cos squared alpha. Okay, now that's all. The only thing I need to rearrange it. So when I write it again, y is going to be u x sine alpha over cos alpha. Yeah, ux is there. Yes, sorry, this u and this u will get cancelled. So there will be, yes, x sine alpha or cos alpha. This u and this u got cancelled. X sine alpha over cos alpha minus this g over u squared, g squared, sorry, g x squared over 2u squared into 1 over cos squared alpha. Okay, so you know that sine alpha or cos alpha tan alpha, sine alpha or cos alpha tan alpha, 1 over cos alpha sec alpha, you know that 1 over cos alpha equal to sec alpha. So it's going to be 1 over cos squared alpha. 1 over cos squared alpha will be square of it. So sec squared alpha. We know that sec squared alpha equal to 1 plus tan squared alpha. Sec squared alpha equal to 1 plus tan squared alpha. You must know these things. So I'm going to rearrange these things now. So 1 over cos squared alpha, I can write sec squared alpha. So it's going to be y is equal to x tan alpha minus g x squared over 2u squared, g x squared over 2u squared sec squared alpha. Now sec squared alpha I can write 1 plus tan squared alpha, x tan alpha minus g x squared over 2u squared into 1 plus tan squared alpha. This thing they asked to show. Yes, right, we got the answer. Remember that in this derivation, we took vertical displacement y and the initial velocity vertical component are the same, which is upwards. Okay, B part, this diagram is given. A small ball is projected from a fixed point A with speed u meter per second at an angle theta above the horizontal. The point B is horizontal ground and is vertically below point A with AB 20 meters. The ball hits the ground at C where BC 30 meters. The speed of the ball immediately before it hits the ground is 25. So it's just actual speed, not horizontal component, not vertical component. Actual speed is 25 meter per second. The motion of the ball is modeled as a particle moving freely under gravity. Use the principle of conservation of conservation of mechanical energy to find the value of u. Okay, so it's initially at A, finally at C. C is below A means loss in GP equal gain in kinetic energy. So that's all. So we can say loss in GP, gravitational potential energy, gain in kinetic energy. So loss in GP means mgh, initially here, finally here. H is 20 meters. So we'll write mgh equal gain in K half mv squared minus half mu squared. So m will get cancelled. So gh 9.8 into h is 20 half v squared 25 squared finally minus half u squared. Everything we know, just find the u. Okay, so you will get u is equal to square root, we have to take it 15.3 meter per second. 15.3 meter per second. That's the initial speed. You can use normal projectile motion also, but here they are asking to use the energy equation. Otherwise, you can resolve and find the time and do. But here they ask to find the by using energy equation. So that's what we did like this. Okay, last part, C part. Find the value of theta. Okay, so that's not an issue. Find the value of theta, the last part. For that, I am going to use the equation what we derived, that is y is equal to x tan alpha minus gx squared over 2u squared into 1 plus tan squared alpha. We derive this thing. Alpha is the angle with the horizontal line. So this is given as here theta. Doesn't matter. Instead of alpha, we need to replace theta. But there I told again the direction of y, the vertical displacement, the direction of velocity is taken same when we were deriving it. But when we are using it careful, here the direction of displacement y is downwards, initial velocity is upwards. So when we are using it carefully, we have to think about the direction here. Okay, now we can use this equation because we know x is the horizontal displacement. During that horizontal displacement, we should know the vertical displacement. That is, when the horizontal displacement is 30, vertical displacement is downwards 20 meter. So everything we know, only thing alpha is unknown. We'll get a quadratic equation. So careful, y is downwards here. When we derive it, we took vertical component velocity up, vertical displacement also up here. Vertical displacement is down, initial vertical component velocity is up, so we have to put minus sign here. Okay, so we'll substitute the value. So this is going to be minus 20 equal to x is 30 tan alpha minus 9.8 times 30, x is 30, 30 squared over 2 times u squared, u we found 15.3. So if you square it, you will get 233. Actually we will get before one step, you will get u squared equal to 233. Then square root u equal 15.3. So I skipped that. So u squared 233, we will put it 233 into 1 plus tan squared alpha. Okay, we'll solve it. You will get a quadratic equation, cross multiply everything and get it. So this, if you solve, you will get 18.93. So that is minus 20 equal to 30 tan alpha minus 18.93 into 1 plus tan squared alpha. Okay, rearrange it. It's a quadratic equation in tan squared alpha. So you'll get 18.93 tan squared alpha. When you multiply inside, you'll get 18.93 minus, but you bring it to left such that it become positive. 18.93 tan squared alpha minus 30 tan alpha minus 1.07 equal to 0. So it's a tan squared alpha, but it's a quadratic equation. You can imagine tan squared alpha as a just something like x squared. So solve it. Whatever here, it's don't worry. This is tan squared alpha, tan alpha 1.07. So it's like a x squared minus 30x. It's like that. 18.93 x squared minus 30x. So whatever it is, like a quadratic equation. Use your calculator and solve to get the real values, actual values for tan alpha. So if you solve it, tan alpha is equal to quadratic equation. Solve it. Tan alpha is equal to either 1.62 and quadratic equation. So we use and. Tan alpha is equal to minus 0.03. That means if you solve it, you will get alpha is equal to, take tan inverse, 58.3 and alpha is equal to negative 1.71 degrees. So this is can't be a negative answer. So okay, I'll keep it as alpha, but it's theta, doesn't matter. So okay, only thing I need to put theta here, doesn't matter. They use theta, use alpha, change everything theta. That's all, nothing. Only thing I need to change the notation because they gave theta there. So tan theta means theta equal, I used the previous equation, so I used the same alpha. But anyway, you have to show theta as alpha. Alpha has to be replaced by theta because in this question, the horizontal, the direction of the velocity with horizontal line is theta. Doesn't matter. The answer won't go wrong, only the notation I changed it. Okay, so theta could be either 58.3 degree or negative 1.7. So here it can't be a negative angle. So the correct angle theta equal 58.3 degree. Okay, so that's all this paper. I hope you understood. We'll meet during another discussion, during another topic. Yeah, bye.